to solve x-intercept for this graph, okay, for this graph, I need to make y equals to 0. Okay, all the x-intercept is solved by the same way. So I'll say when y equals to 0, what I want to solve is 2 cosine 2x minus pi over 3 plus root 3 equals to 0. 10, like I'm writing things on page 9, so it's page 10 equation. Okay, the first step is I want to move every coefficient constant to the left hand side. I want to see cosine 2x minus pi on 3 equals to negative root 3 over 2. Okay, move the root 3 to that side and divide by 2. So it's minus root 3 divided by 2. Okay. Now it's a little bit harder compared to the previous exercise we did because it's a negative value. Cosine something equals to negative. Okay, if we meet negative questions, we think about positive first. Okay, we want to think about the reference angle because only the same reference angle can give you root 3 over 2. So I want to ask you cosine what equals to root 3 over 2? Give me the 0 to 90 degree angle. Pi on what? Pi on 6. Okay, cosine pi on 6 is root 3 over 2. Okay, now what I required? I required negative. Okay, tell me in which two quadrants the cosine will be negative? Third. Yep, second and third. So C, A, S, T. So S and T are not the cosine quadrant. That will be negative. Okay, the angle in those two quadrants will be negative. So my first two answers must be in those two quadrants. Okay, how large should be this angle? The reference angle needs to give you pi on 6. Okay, the reference angle needs to give you pi on 6. So this angle needs to be pi on 6, and this angle needs to be pi on 6. So the actual angle we're talking about is this angle, 5 pi on 6. Okay, 5 pi on 6 is an angle in the second quadrant, which is the sine quadrant, with a reference angle pi on 6. So cosine, cosine 5, you think about the reverse way. Cosine 5 pi on 6 will be negative cosine pi on 6. And that gives you negative root 3 over 2. So that's how this negative sign coming from. And the next angle is this angle here. That's a 7 pi over 6. That's a 7 pi over 6. Okay, pi plus pi on 6. Therefore, 2 bracket x minus pi on 3 equals to 5 pi on 6 and 7 pi on 6. I'll divide the 2 to that side. So I say x minus, I'll make a denominator 12 because right hand side obviously won't become a 12 denominator. So that is 5 pi on 12 and 7 pi on 12. So what x will be is 9 pi on 12 and 11 pi on 12. Okay, 9 pi on 12 will be a 3 pi on 4. Will be a 3 pi on 4. That's the first two value in the first period. Okay, that's the first two value in the first two period. The next thing we'll think about is the period. Okay, what do you think the period for this graph? 2 pi divided by 2. So it's pi. Okay, period is pi. Divide by this 2. Okay, period is pi. So I can write the general solution. Okay, I want to give you notice that general solution is very important for year 12. not year 11. Like year 11, you may not really be asking much questions about general solution. But the year 12 students, the SEC they just finished yesterday, there are questions like general solution, and everyone tell me that they don't know how to do general solutions. They're not good at it. Well, if they don't, well, like for example, this question, what we're trying to solve is in between 0 to 2 pi. Okay, in between 0 to 2 pi. So we're asking for specific solution. You can skip the general solution. Without writing the general solution, you can directly give the specific solution. But if they ask, say, if there's no domain given, the x can be anything, then it must be general solution. The answer can be infinitely many numbers, so it must be a general solution. Yeah, they ask a lot. Well, can't say which one asking more. It's like half chance to get each other. Okay, so I think general solution can help us. Like, I don't know why students don't get it, because actually the specific solution is coming from the general solution. We have the general solution first, and then we have the specific solution. Because each solution, we need to, okay, the first solution will be x equals to 3 pi over 4 at k times pi. You times k period. 1 period, 2 period, 3 period, k period. Where k belongs to z, that's something you must write. Okay, k belongs to z, that's something you must write. The second one will be x equals to 11 pi over 12 plus k pi, which k belongs to z as well. I want to say there's multiple ways of writing general solution. They are not unique. Okay, they are not unique. You can have infinitely many ways of writing general solutions. That's only one possibility to write in this way. On the book, they normally write, okay, they always write what? Make the same denominator. For example, this one. They want to make 3 pi plus 4 pi k over 4. Okay, they put that in like same denominator and write like a whole fraction. That's what the book solution looks like. I think my solution is quite obvious. That's the first solution, add or subtract period. Okay, many period. So this is more clear way of showing you what you're trying to do. And that's an easy way for calculation when you substitute k values. That's an easy way for substitution. So you can write both. And your calculator can give you general solution as well. I'll just show you that on the calculator because it's very important. A lot of students don't understand the notation from the calculator, so I'll show you today. Try to remember that, okay? I have menu 3.1. What I want to solve is cosine graph. 2 times bracket x minus pi over 3. I want this value equals 2 minus root 3 over 2. And I'll solve for x. Okay, why I type my equation like this as what I write? Okay, there's infinitely many solutions. That's the first thing you need to know. There will be infinitely many solutions here. So your calculator can't list out all the solutions for you because it's impossible to list out all of them. So when I press enter, what it gives me is that, okay, copy this somewhere on your page first, like just near somewhere. That's given notation, that's a calculator notation. That's what you put this equation into the calculator gives you that. Okay, the thing here is this n1. What does n1 represent? It's like the k. This n1 is the k value, the k we talk about. The calculator just can't tell you n1 is z. Okay, n1 is z. They can't write that out. So, but you need to know that n1 is an integer number, which is the same as the k we're talking about in our general solution. You just need to copy those two things down and say k belongs to z, or n belongs to z if you use n. Okay, so that's the two general solutions. You can have a look. This is different from what we get. Okay, this is different from what we get. But both solutions are correct. Okay, doesn't matter if you use by hand approach to find the general solutions, or you use calculator to find general solutions, or even there's more ways to represent general solutions. They are all correct. You just need to be able to find one way to do it. Okay, just find one way to do it. So I think the good way will be find the first two solutions, add or subtract period, and the calculator. Okay, those two things you need to know. So by calculator. Question?
Why is it like 4 and 1 minus 1?
Which one?
On the answer.
What's wrong? Like, what asking? Can I say that again?
Well, let's say like 4 times n minus 1 times n multiplied by 4. This is just how it is.
Do you mean why the solution looks like that?
Yeah. This is just how it is.
No, like, it is also calculated by the same way we calculated. Because when we calculate our first answer, like we calculate those two as our first solution, the calculator can find another two starting point. It's not necessary to be in between 0 to 2 pi. It can be in between 2 pi to 4 pi. It can be in between negative 2 pi to 0. Well, they just find any two solutions in one period and then keep adding or subtracting. So the starting point not necessary to be those two values. It can be any possible values along like the curve, like any two intersections, and what must be the adjacent ones, and then add or subtract period. Okay, what the N1 represent? Why there's a N1? The N1 means the first variable, and if you solve another circular function after this, that will give you an N2, which still means the K value. You just need to know the N means the K value. Okay? That's the general solution. Okay, that's the general solution. And we can solve for the specific solution because we only have value in between 0 to 2 pi. So we're not necessary to use the general equation to represent. So let's write the first one. The first one is 3 pi over 4. Okay, first I'll subtract. If I subtract the period from that, that becomes negative pi on 4. And we won't have this answer. Okay, it's out of 0. It's out of 0. And I can add pi. That will get 7 pi on 4. Which is correct. I can add another pi. That's 11 pi on 4. Which is out of the domain 2 pi. So we'll stop for this solution, okay, for the first equation. And for the second one is 11 pi on 12. Well, if I subtract pi, that's minus pi on 12, which doesn't work. I can add another pi. That will be 23 pi on 12, which is correct. If you add another pi, that's 35 pi on 12, which is obviously out of the domain. We won't have that one. So the 4 possible solution is those 4. Okay, the 4 possible solution is those 4. So in order, I will write it as, so x equals to 3 pi over 4, 11 pi on 12, 7 pi on 4, and 23 pi on 12. And the ability also needs to know is how to use calculator to solve for specific solution. You don't want the calculator only give you a general solution and then you're trying to solve 1, 2, 3, 4 to find a specific solution. So what you need to do is, calculator's here. Okay, I'll just copy this this equation down. Okay, what's our domain for x? What's the domain for x? 0 to 2 pi. Okay, 0 to 2 pi. If it's 0 to 2 pi, I will just have a bar here, and then put the domain here. Oh, wrong. It's a smaller equal sign. Okay, put a domain here. To tell the calculator, I only want the possible x values in between 0 to 2 pi. Okay, if you not put this domain, the calculator only gives you general solution. If you put the domain, the calculator will give you the specific solution because it's possible to list out all the values in between 0 to 2 pi. And we press enter. We have those 4 values we have solved out. Okay, a lot of students solve circular function and tell me, oh, I can't find the value because I haven't restricted the domain. If you not restrict the domain, you can't see specific solution. You can only see general solution. Okay. Okay, so that's calculator, the use for calculator and solving that. And come back to the graph. I need to label all of those points. Okay, the first point here is 3 pi over 4 comma 0. That is 11 pi over 12 comma 0. This is 7 pi over 4 comma 0. And the last one is 23 pi over 12 comma 0. That's a lot of points worth us to label. If you say like, is there any point is not necessary to label? I think it's the middle two. Okay, those two you are not really need to label them because they are not special points. They're not really special points. Special points are maximum, like turning points, x-intercept, y-intercept, endpoints. These are the points you must label. So this is just some point on the midline. You don't really need to label them. And please read the question carefully. Last year there was a question asking, please label only one maximum point or minimum point on this circular function graph. And a lot of students label all of them. Okay, they read it. Okay, they read it. I see some of them highlight that one intercept, and they think, oh, it's okay to put more. Okay, just follow the instruction what is asking you to do. Okay, read the instruction what is asking you to do. If they said just label one turning point, just label one for them. Do not label a lot. It wastes of your time and you are not doing what the question is asking you to do. Okay, so let's keep going for next question here. Okay, question 2. I'll give you 2 minutes to solve this by yourself. Okay, I'll give you 2 minutes to solve question 2 here. Okay, first, I need to make cosine 3x minus pi over 3 equals to -1/2. Okay, that equals to -1/2. What do you think about is, first, it's negative. I'll think 2 things now. Cosine what equals to 1/2? Okay, most of you know that cosine pi on 3 is 1/2. Okay, cosine pi on 3 is 1/2. I want negative. I want negative. Negative will be in the second and third quadrant for cosine. So you draw 2 angles in the second and third quadrant with reference angle pi on 3. Okay, those 2 reference angle is pi on 3. So the actual angle is 2 pi on 3 and 4 pi on 3. Okay, 2 pi on 3 and 4 pi on 3. So I know that 3x minus pi on 3 is 2 pi on 3 and 4 pi on 3. Okay, because cosine 2 pi on 3 will be negative a half, 4 pi on 3 will be negative a half as well. For sine and cosine, I need to solve two values. Okay, I need to solve two values. And I'll add pi on 3. That's 5 pi on 3. And I will divide by 3. Pi on 3 and 5 pi on 9. Okay, I have solved the first two positive solutions out already. Now, all the other solution will relate to those two values, which will be adding periods or subtracting periods. Okay, adding periods or subtracting periods. So I'm interested in the period. The period will be 2 pi over 3. Pi over 3. Okay, I will first have pi over 3 here. If I subtract 2 pi over 3, I don't have enough space. Okay, let's write in horizontal. Okay, pi over 3. Let's subtract 2 pi on 3, which will be minus pi on 3. Okay, is minus pi on 3 within the domain or outside the domain? Within or outside? Can I take this value? Can I take negative pi on 3? Yes, it's negative 2 pi on 6. Here is negative 3 pi on 6. So it's still within the domain, so I can take this one. So I need to try the next one. So next one will be minus pi. Because minus pi on 3 will subtract 2 pi on 3. Okay, we'll subtract 2 pi on 3. Minus pi. Definitely not going to be the solution. And I can add to this side. And after I add 2 pi on 3, I get pi. Okay, pi is fine. And I'll add another 2 pi on 3. I'll have 5 pi on 3. That's still less than 2 pi, which is correct. And I'll add another 2 pi on 3, which is 7 pi on 3, which is still fine. Add another 2 pi on 3, which is 9 pi on 3, which is 3 pi, which is fine as well. Adding, you just keep adding. You keep adding periods after one. Okay. So reach 3 pi, like there's no point I keep adding anything. Like it's already reached the boundary point. So that's my first solution. I see some of you start to add things from here, like okay, I know this method, and some of you just write 8 pi over 3. I know like some teacher teaching in different ways, like they start to calculate, listing all the possible values out, starting from that step. But like I personally don't like this method. If you feel like that's comfortable to do, I'm fine with it. But personally, I don't like it because how many value you list out? Like for this one, after I calculate the x, adding period on x, I know I must stop at 3 pi. I must stop at minus pi on 2. But when you start to listing out all the values in this box, what value you will stop? The domain for x is negative 2 pi on 2 over 3. So you need to find the domain for 3x minus pi on 3. Okay, you need to find the domain for that. You want to find the range, what possible values for this equation. So 3x. For 3x, you have minus 3 pi on 2 to 9 pi. and then you will minus a pi on 3. Okay, you will minus a pi on 3. So you need to subtract pi on 3 on those two numbers as well. Then that's the possible numbers you need to list in this box. And can you see you actually do a lot of extra calculations. You find another domain for 3x minus pi on 3, which is extra work. That's why I'm not really recommending you to do this at this time. So I'll recommend you, after you solve out the first 2x, you add in period on x, and you exactly know what is the boundary for x. And you will exactly stop there. You don't need to do extra working. Okay, so that's my suggestion. Okay, that's the first value, and I also have the second value, 5 pi on 9. Okay, this period can also be written as 6 pi on 9. Okay, times 3. Make the same denominator 9. I will subtract from 5 pi on 9 first. I will write 5 pi on 9 here. They are the corresponding values. I will subtract 1. Okay, after I subtract, I have negative pi on 9. Do you think it's within the domain or outside the domain? That's still within the domain. Then I will subtract another one. That's negative 7 pi on 9. Do you think that one will work or not? No, because that's negative 14 pi on 18. That is 9 pi on 18, so it's out of the domain. So I won't have this value here. Then I will keep adding to them. Okay, that's 11 pi on 9. I'll add 6 pi on 9 to that. That's 11 pi on 9. I'll add another one is 17 pi on 9. Yes, you keep adding. 23 pi on 9. Add another one is 29 pi on 9. Is that one working? No. 27 pi on 9 is the last number you can have. So that one outside. So I won't have this one. So all the possible solutions are here. Yeah, all the possible solutions are here. I have no space, so you better write so x equals to list them in order. Okay, list them out in order. Yep. Yep. Yeah. Okay. So you will say x equals to what? Write your final answer out. Well, in the exam, it's not going to be this much solutions. Like, with 4 or 6 is the maximum, I assume. It's not going to have like 10 numbers listed out. Okay. This question, I just retyped the 3 twice. So I don't have the 3 here. So you only solve for sine 2 bracket t minus pi 4 equals to 1. Okay, 1 is a magic number in sine and cosine. Minus 1 is also a magic number. Why is like that important? What's the important thing for 1? Sine something equals to 1. 1 is what? Well, can I have 2? No, so what's 1? Can I have 1.5?
It's the maximum.
Yes, it's the maximum. Okay, 1 is the maximum point. Minus 1 is the minimum point of sine. So we're trying to solve for maximum or minimum. I only have 1 value listed. Here we all have like 2 value listed. Okay, on this one I have 2 value listed. But when I solve for 1, only 1, or negative 1, I only have 1 value. Because in each period, there will be only 1 point of intersection. So what's my 2t minus pi on 4 equals to? Sine what is 1?
Pi on 2.
Pi on 2, okay. So I have pi on 2 here. So t minus pi on 4 is pi on 4. T will be pi on 2. Okay, so far t is pi on 2. Okay, if t is pi on 2, what's the period? It's 2 pi over 2 is pi. So t will equals to pi on 2 plus pi times k, where k belongs to z. That's the general solution. I haven't write general solution for the previous question. It's no space. Okay, I have a general solution here. Yep. No, you don't really need to write it. Like if, as I said, if you're asking for specific solution, you write specific. If it's asking general, you write general. But it doesn't matter because my specific solution is actually coming from the general. You can list it there, or you don't really need to. Okay, pi on 2. If I add a period, it's 3 pi on 2. If I subtract a period, it's negative pi on 2. Okay, negative pi on 2 is out of the domain. I won't have it. 3 pi on 2 is 6 pi on 4, out of the domain as well. So the only solution is t equals to pi on 4. Pi on 2, sorry. So t equals to pi on 2 only. T equals to pi on 2 only. All right, I'll stop here today. I'll just finish solving, and next lesson I will go tangent graphs. Okay, one lesson for tangent graph, one lesson for solving tangent, and one lesson for circular function application. So it's about 3 more lessons next week. Oh, I don't have enough. Oh, it's fine. I can do graph and solving together maybe. Okay.